Now you see the reaction of lead nitrate with NaCl gives rise to double displacement reaction. You know that PbCl2 is soluble in hot water, right? That means it is insoluble in cold water. However, when you are adding excess of HCl, you will be getting H2 PbCl4. So this is what is making it soluble. So right answer for this question will be option C. This is regularly asked question. So go through carefully. Very easy question as well, right? Now let's see the next question. You can see here that which of the following liberates oxygen gas upon hydrolysis, that is reaction with water. You know that this Pb3O4 is insoluble in water. So there is no point that this will react, isn't it? Now you know that Na2O2 when undergo hydrolysis gives rise to what? NaOH and H2O2. Alright, and you know that lithium peroxide gives rise to what? Lithium hydroxide and H2 gas is evolved, isn't it? However, when KO2 reacts, that is superoxide, where the oxidation state of oxygen is -1/2, when this reacts with H2O, the products obtained are KOH anyways, H2O2 and oxygen gas. You need to know that here oxygen changing from -1/2 to -1 as well as 0. So this oxide is remaining intact here. So you can see -1/2 to -1 is reduction, and that itself is undergoing oxidation to give you the oxygen gas. So only one substance which is giving rise to the oxygen upon hydrolysis is potassium superoxide. Very frequently asked question. The superoxides give rise to the extra oxygen because it has extra oxygen. That's what called superoxide, isn't it? So which among the following statements are true for the extraction of aluminum from bauxite? You have to focus on bauxite, the structure of diborane, and the structure of inorganic benzene, the acidic strength of boron trihalides, because these are all the frequently asked questions. Like you know that addition of Na3Al, because you know this is coelectrolyte, which I discussed in the beginning questions also. So used to lower the melting point and increase the conductance. CO is evolved at the anode. You have seen that the carbon reacts with the oxygen evolved at the anode to give you CO2, and the cathode is steel vessel with lining of the carbon. Yes, this is the absolute fundamental. And hydrated Al2O3 precipitates when CO2 is bubbled through the solution of sodium aluminate. Yes, that's true, because the purpose of adding the CO2 is nothing but the neutralization of the solution and also the precipitation of the Al2O3. So this we study as the fundamentals of the electrolysis of the bauxite. So all the options are correct here. Go through, it's in your NCERT textbook. Very important, very frequently asked. Which of the following statement, you know that tin is stable as +4, lead is stable as +2 because of inert pair effect. So this is a very strong reducing agent. We have seen in multiple reactions, like you know HgCl2 reacts with SnCl2 to give you Hg2Cl2 and SnCl4, etc. Very frequently seen because the oxidation state of tin is stable as +4, lead is stable as +2 due to inert pair effect. And next is what? This is true. Alright. So SnO2 reacts with KOH. Yes, this is absolutely correct. Gives rise to K2 SnOH taken 6. This is also correct. Alright. What else we have? You can see here the only point is you have to understand that here the oxidation state is +4, and here the complexation is taking place where the oxidation state of tin remains as +4. That's all right. You know, complexation. This is not a redox reaction. This could be a redox reaction provided this reagent is an oxidizing agent. But we know that this is not an oxidizing agent. Hence, this cannot be the redox reaction where there is the tin remains as +4 only. Next, you can see option C. Solution of PbCl2. We have discussed this. Another question was also asked when added to this thing. So you will be getting what? 2 moles of H plus and PbCl4 minus 2. So these are the ions that are obtained, but not Pb plus 2 and Cl minus. So this is a wrong statement, and you can see Pb3O4. I told you that you need to consider this as 2 PbO and PbO2. Dilute HNO3. What is that you are adding here? Dilute HNO3. So you can see that dilute nitric acid, hot dilute nitric acid to give PbO2 in the redox reaction. That means here lead got oxidized. So you got PbO2. Let's see the possibility, isn't it? Instead of remembering. So PbO2, the oxidation state has changed. Alright. Because you know that this is oxidizing agent, so there is a possibility, it's not that it won't happen, so there is a possibility that it will happen. Along with that, you are using this, so the product may be N2O and water. I am not sure about this product, that depends upon this dilute. If you take, you will be getting, however hot might what you call make it further undergo the oxidation to give you NO or NO2 also. So let's not focus on this. Let's understand that yes, it will form PbO2, a stable compound of lead when oxidized by using HNO3. Now